Question number 19. We have been given a table. So number of cars is one part and maximum number of passengers and crew is the other one. So for 3 cars, 174 is the maximum number of passengers and crew. For 5 cars, maximum number of passengers and crew is 284. And for 10 cars, there's a maximum number of passengers and crew to be 559. So the table shows the linear relationship. So it's mentioned that it's a linear relationship between the number of cars C on a commuter train and the maximum number of passengers and crew P that the train can carry. So which equation represents the linear relationship between C and P? Now, since it's given that there is a linear relationship between the number of cars C on a commuter train and the maximum number of passengers and crew P that the train can carry, it follows that this relationship can be represented by an equation of the form P is equal to mc plus b, where m is the rate of change, or in other words slope, where m is the rate of change of P in this relationship and b is a constant. The rate of change of P in this relationship can be calculated by dividing the difference in any two values of P by the difference in the corresponding values of C. So in other words, just like for slope, we use y2 minus y1 divided by x2 minus x1, that is the slope formula. Here these are our x values. Let's say this one is x1 y1, this one is x2 y2. In other words, we will take the difference of any two values of P and we will divide it by the difference in the corresponding values of C. So what will we get? So we will have 284 minus 174 divided by 5 minus 3. So this minus this divided by 5 minus 3. So what we will get? So we will just simplify this. (284) minus 174. So we get 110. So this 110 we will divide by 2. So we get 55. So substituting 55 for m in the equation, P is equal to mc plus b. So we also need the y-intercept because it's a linear relationship, and now we know the slope, which is 55. So substituting 55 c plus b. Now the value of b can be found by substituting any value of c and its corresponding value of p for c and p. So respectively in this equation. So we will, let's see, we can use the last 10 and 559, let's say. You can use any, but let's use this one. So we will get 559 is equal to 55 times 10 plus b. So 559 is equal to 550 plus b. Then subtract 550 on both sides. So we will get b to be equal to 9. So now we know both the values of the slope and the y-intercept. So our equation will be P is equal to 55 c plus 9. But you can see that it is given in this form. The c and p, all of them are on the left hand side and only the constant is on the right hand side. So we have to push these terms to the other side. Or in other words, let us subtract p on both sides. So we will have 0 is equal to 55 c plus 9 minus p. Then subtract 9 on both sides because we need the constant on the other side. So negative 9 is equal to 55c, and the 9's cancel, minus p. So let us see, this is matching to which one. So you can see that it matches to answer choice A. So choice A is correct. Of course, we have written in the other way, 55c minus p is equal to minus 9. If you just push the left hand to the right, left hand terms to the right hand and the right hand terms to the left hand side, we will get what is matching from the answer choices. So 55c minus p is equal to negative 9. That is the relationship. So all we had to do was use a set of terms to find the slope and then use another term to calculate the y-intercept, and then rearrange.